everybody, it's Ms. Phoebus and I'm back with another lesson, lesson 61, linear regression and correlation coefficient. So we're going to go back into the linear regression idea. We're going to look at what slope and y-intercept mean to the context of a real world situation, and then we're going to look at this correlation coefficient and see what it can tell us. Okay, so the skills for today, we are going to interpret slope and intercept from a linear model in the context of the data and compute with technology the correlation coefficient of a linear fit and interpret its meaning. And those are basically our standards for today. We're going to be on page 307 of the notes. And on page 307, you should see this. And we have our linear regression. This is the top part of the screen of a calculator. And this would be what we are using to write our equation, y equals ax plus b, not m. Remember, m is replaced with a. So in the last lesson, we wrote equations of the line of best fit using the graphing calculator. Recall that a represents slope, while b is y-intercept. Many questions will ask you to interpret the slope and y-intercept of a graph or table or situation. The y-intercept is the b value. This is the y value when x is 0. The a is the slope of the line. If the a is positive, the line is increasing. If the a is negative, the line is decreasing. So here we go. Example 1. Data was collected on the depth of a dive of penguins and the duration of the dive. The following linear model is a good summary of the data, where t is the duration of the dive in minutes and d is the depth of the dive in yards. The equation for this model is d equals 0.015 plus 2.915t. They want us to interpret the slope and interpret the y-intercept. And then we're going to use the equation to predict the depth of a penguin who swam 4.2 minutes. So what we're going to do is we have to not only state what the slope and the y-intercept are, but we have to give meaning to it. But for the first part, we are going to state what it is. So the slope is 2.915. Why is that the slope? Well, that's what is in front of the variable. Remember, it's y equals mx plus b. M is the slope. It is in front of the x. We don't have x's here. We have t's. So 2.915 is the slope of the line. The y-intercept is 0.015. I know that that's the y-intercept because it is the number that's just hanging out here, and that is just a number, no variable with it. So the question is, what is going on in the problem? So we know that we have two variables. We have t being the duration of the dive in minutes, and d being the depth of the dive in yards. So we are looking at slope being a rate of change. And when we look at slope being a rate of change, we always look at slope being change in y over change in x. But we don't have y's and x's here. We have t's and d's. So this is really change in d over change in t. So change in d, that's change in depth of yards, like how far they dove down in yards, over change in time in minutes. So this is 2.915 yards per minute. So what does that mean? I'm writing that right now just so that you can see what I'm thinking. But that means that when a penguin is diving, that's their speed. That's how fast that penguin is traveling. So what I'm going to do is I'm going to write a little statement. So the penguins are diving at a speed of 2.915 yards per minute. Now, I know that we have 2.915 in two places, but again, this was my thought process. I identified the slope, then I thought about what did it mean, and then I wrote a sentence interpreting what that slope means, including units. Okay, so when you write this out, you need to look at what are the variables representing. If they don't use x's and y's, look at what variables they use. What they didn't use x. Oh, what did they use in place of x? Oh, they didn't use y. What did they use in place of y? And go back to this idea of slope is change in y over change in x, then change the variables up a little bit, and then look at what each variable represents. D is yards, T is minutes, yards per minute is a speed. All right, let's interpret the y-intercept. So 0.015, so that means D is the depth of the dive in yards. So the penguins start out at 0.015 yards into their dive. So they're already kind of in the water in their dive process when time starts. At time equals 0 minutes. Okay, so there is a meaning to the y-intercept you have to figure out, and it always goes back to, well, what is our x value, or in this case, our t value? When is it 0? What is that going to indicate? And then again, go back to the units for our y value, or in this case, our d value, and what do they mean? Right, so then what we can do with these equations, these line of best fit equations, is we can make predictions. And so the best thing that we can do is we can take our equation, and here they give us a time, 4.2 minutes, and what we're going to do is we're going to plug it in for t, and we are going to get a prediction. Now, is that going to always work out the same for every penguin? No. It's not, but this is like a predictive value. So what we're going to do is 0.015 plus 2.915 times 4.2, and I'm just going to stick that in the calculator. But I do want to see when you are putting things in the calculator, show me what you're putting in. So if you're putting something in the wrong spot, or putting in the wrong number, then I can help you out. All right, so we're going to get 12.258, and that is yards. So based off of the data that was collected, they built a model. And then that model we've used to predict a penguin who swam for 4.2 minutes would have dove down 12.258 yards. And so what we're doing is we're bringing all of that back into the idea, the context of the situation. All right, example 2, data was collected on the number of absences a student had from a college class versus the final grade in that class. The following linear model has been calculated where x is the number of absences and y is the final grade percentage. The equation for this model is y equals, and we're going to make a change here, y equals negative 3.62x. We're going to change this to plus 102.49. Makes more sense this way. All right, so what I want you to do is I want you to, based off of the equation, I just want you to identify and write down what is the slope, what is the y-intercept. That's all I want you to do. Pause the video now. All right, the slope is negative 3.62. Our y-intercept is 102.49. So we're going to come back and we're going to talk about units and try to figure out what this means. We're also going to later on predict the number of absences a student has if they have a 78% as their final grade. Okay, so with our slope, we're looking at change in y over change in x. And so change in y is the final grade percent, so we're looking at our grade percent divided by x is the number of absences. And it's going to be negative because as the grade percentage goes up, our number of absences should be lower. And then if our grade percentage goes down, that's probably because our absences are higher. And so they have that inverse effect. Both of them don't agree. They have, kind of opposite things going on. So we are going to know that that is a negative slope. So that means that we're looking at percent of a final grade decreasing, right, because we have a negative slope per number of absent days. So we're looking at final grades will drop 3.62% for every absence. Okay, now when we look at our y-intercept, that's where our x value is 0. So that means we have 0 absences, and that's why we needed to change it. At 0 absences, we should expect, it looks like, to get 102.49. Now, that may be impossible. We don't know. Maybe there's some extra credit in some classes. So what this would mean is that students who don't miss any days should have a final grade of 102.49. Again, we're not 100% sure if that's possible, but that's at least what the units and that number are telling us. All right, so then now what we're going to do is we're going to predict the number of absences for a student that has a 78%. This is a y value. So what we're going to do is we're going to plug that in for y, and we're going to have to solve for x. Didn't give you a whole lot of space, so we'll have to make do. So we've got 78 equals negative 3.62x plus 102.49. So we're going to subtract 102.49. So we are going to get, break out my calculator here, 78 minus 102.49 is negative 24.49. And that equals negative 3.62x, and we're going to divide by negative 3.62 on both sides. And so x equals 6.77, so roughly 7 days. So they probably made, or they probably had about 7 days that they were absent, 6 to 7. Here's example number 3. Find the equation of the line of best fit using the data in the table. So they want us to write a linear regression. They want us to identify and interpret the slope, identify and interpret the y-intercept, and use the equation to predict the net worth of someone who is 18 years old. So we are looking at breaking out the calculator. We're going to have to use the headings on the table to really know what's going on. So we have age and net worth in billions of dollars. So know that this is not your average 18-year-old. Just know that. Okay, so I'm going to have to clear out all my stuff. And I'm going to hit Stat and Enter. And there's my table from the last time you saw it. And what we're going to do is we're going to clear everything out. Clear, enter. All right, and so what we're going to do is we're going to put age in L1. We're going to put net worth in billions of dollars. Now, you could put all the zeros. It's not going to probably be very feasible to do that. So what we're going to do is we are going to just keep these numbers, but when we write and we talk about this, we have to remember that this is not just dollars and cents, that this is in billions of dollars. So that unit is important. So we got 60, 72, 56. All right, I'm going to fill out the table. You can fill out the table with me, but I'm going to kind of probably cut some of this out. So I'll see you on the other side. All right, one thing that I am going to do is show you, my table is almost complete. I left this one blank. Let's say that I thought I was going to put it in and I thought I already put it in and I just went ahead and went on to the next thing. Sometimes an error comes up and you're not sure why. So I wanted to just show you that if you do stat, right, and for, and you go through the whole entire process, it is going to give you a problem. It says there's a dimension mismatch because I have so many, was that like 10 or something, 10 ages, but only 9 net worths. So if I go to, it'll take me to, and hover over the problem. There's a problem in L2. So I need to go back to my table and I can see that, yeah, not everything has a partner. And then go and explore, and maybe I skipped one early on. I skipped the last one on purpose, so it's not always the last one. But just keep in mind that that is something that can happen. Everything in L1 has to have a mate in L2. All right, and then if you type in a number wrong, like I said in the last video, you could potentially get an incorrect answer. So if you're doing like a multiple choice question and your answers are off a little bit, you might want to go back and just double check and make sure that everything in your tables are correct. All right, so we're going to write our function, and so we're going to do stat write for, and then we're going to hit enter a whole bunch of times. All right, so there is our equation. So we're going to write down y equals 0.45. X minus 3.51. And then we're going to identify the slope. So 0.45 is our slope, and negative 3.51 is the y-intercept. And then we're going to go ahead and interpret what those mean. So that means we need our units. And so we're looking at change in y over change in x. So we're looking at change in billions of dollars per year, basically. So we're looking at accumulating, this would be people have a net worth, or how about this? People gain net worth of $0.45 billion, or dollars in front, per year. Now, this is not true. Pretty sure. Okay, how old you are doesn't always mean that you have a net worth in billions of dollars, but maybe we have celebrities on this list. Not sure. Okay, so this is what happens when you have 0 in your X. That means you're 0 years old. So newborns, people 0 years old have a net worth of negative $3.51 billion, which is a lot of money. I would say babies don't have any money, but I don't know if they owe people that much money. So the whole idea is we're trying to state a relationship. We can come up with an equation and be able to interpret the slope based off of what the variables are representing. But does it always represent a nice, strong, causation? Something causes this. As your age increases, your net worth in billions of dollars should increase, that kind of thing. That's something to talk about later. All right, so let's say we are dealing with celebrities, and we're going to look at somebody who's 18 years old, which I'm pretty sure you would like your net worth in billions of dollars at the ripe young age of 15. So 18 is not too far away. That just means you have more money, right? So we're going to predict 18 years old. Well, 18 is an X, so we're going to plug into our equation 18. So we've got 0.45 times 18 minus 3.15. And we're going to stick that in the calculator. And we can see how much to predict. Like I said, we're not 100% sure what this is about. But at the ripe old age of 18 years old, you should expect to have $4.59 billion. Again, I don't think that that's happening for most of us. It would be nice though, wouldn't it? All right. Let's look at example 4. Okay, this one's about cars in 10,000s and income. So I'm guessing that this is use the equation to predict the income of a car rental agency that has 20,000 cars. So that means that you see in that statement we had some more information. So we are looking at dealerships that have cars, and these are represented in the 10,000s. So this is not just 8.5, this is 85,000. So how many cars the car rental has versus how much money do they have coming in. So let's go back to our calculator. And again, you should be practicing. If you're not practicing, you need to. We're going to hit stat and enter. Just watching is not enough. I can guarantee you that. My mouse is not behaving itself. Okay. So, skip the table. So we've got 63. Nope. 8.5. 7. All right, everybody's got a partner. Looks like I've got everything in there okay. So then now I'm going to do stat right 4. Enter, 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 enter. And there is my slope of my y-intercept. And I'm going to write my linear regression as y equals 0.11x plus let's go ahead and call it 0.4. All right, and so our slope is 0.11. Our y-intercept is 0.4. We're going to look at our units to determine what those mean, and then we will use our equation to help us predict. So we're looking at, again, change in y over change in x. So we are looking at income in billions of dollars divided by cars in the 10,000s. So we have kind of some unit conversion things happening. So let's go ahead and let's do this. $1 million, right? Over 10,000 cars. So this is one of the things that is a little bit on the difficult side when they start using these other units, is that you kind of need to do a little bit of a conversion. So what I'm going to do is I'm going to take 0.11 and I'm going to multiply it times a billion. So that's a million. So that's a billion. And so what that's going to do is that's going to move my 2 decimal places. So I'm going to have 11 and I get rid of 2 of these zeros. So that means I really have 11, so it's like $110 million per 10,000 cars. And let's clean that up. So, okay, so I have figured out that for every car that they are renting, at this dealership, they are making an income of $11,000. Income of $11,000 per car. And maybe that's over the lifetime of the car. I don't know. Okay, so sometimes, especially when they do this whole, well, this is in billions of dollars and this is in 10,000s of cars, you're going to have to figure out, well, what is it for one? Okay, and so it's a little bit of a conversion process. All right, so then now we've got this 0.4, so we're in the same idea of what's going on. So 0.11 became 11,000. So 0.4, what do you think? I'm thinking becomes 4,000. So this is going to be 4,000, and that's going to be when we have 0 cars. So we're going to have an income of $4,000 with 0 cars to rent. I don't know how that works, but that seems to be what the idea is. But 4,000 in comparison to what we're dealing with billions of dollars, $4,000 is nothing in comparison to $7 billion. So it's close to 0. All right, use the equation to predict the income of car rental that has 20,000 cars. Now, we want to be very careful with this because we don't want to plug 20,000 in right away, because remember that the cars are in 10,000s. So if I want to figure out how many or what to plug in for X, I need to look at dividing that and getting 2. So I want to plug in for X 2. And then get a Y value, and then look at, okay, this is Y values in billions of dollars. So again, we're having to look at that, a little bit of a conversion factor. So if I'm looking at Y equals 0.11 times 2 plus 0.4, well, that's 0.22 plus 0.4, which is 0.62, which means that we've got $0.62 billion, which is going to be in the like $620 million range. Okay, but definitely lower than what car company F had, because they have less cars. All right, so thus far we've been classifying scatter plots as being positive, negative, weak, strong, or having no correlation just by looking at the scatter plot itself or even thinking about the situation. But there's a better way to measure the correlation of variables and making that determination than, and it's by looking at an actual number. It's called the correlation coefficient. So I have this little map here, and even though the number lines, see the little arrows on the end of the number lines, even though they keep going, everything with R, our correlation coefficient, little lowercase letter r, is trapped between -1 and +1. So all the numbers that you could possibly have for a correlation coefficient are between -1 and +1. Now, no correlation, remember that the dots are kind of spread out. There's no relationship between the variables. This is our height, tells us how many test points we're going to get. No correlation, should be close to 0 or at 0 exactly. If we have a strong positive, then we should expect numbers close to 1. If we have a strong negative, we should expect numbers close to -1. So just because you have a -1 as your R value does not mean that it's not strong. So you've got to think either a -1 or a +1. And so negative numbers are just going to imply that you have a negative correlation. Positive numbers are going to imply a positive correlation. And so a correlation coefficient is a numerical measure of some type of correlation between -1 and 1. And so at this halfway point, we have a 0.5. It's a weak positive. And we've got at -0.5, we've got a weak negative correlation coefficient. And so here are some facts about correlation coefficients, represented by the little lowercase letter r. So if they ask you what your r is, they're asking for correlation coefficient. You can also use r to represent the correlation coefficient, so you don't have to write all that out. There are no units for the correlation coefficient at all. It's just a number. The value of R will be trapped between -1 and 1. If the variables switch and x becomes y and y becomes x for some reason, correlation coefficient never changes. If the variable changes units and x and y were measured in inches and then later converted to feet, correlation coefficient will not change. The value of R is sensitive to outliers and can change dramatically if one is incorporated into the data. So an outlier is a number that's like really far out there. It would be really far off your scatter plot, and so it would pull that R and make it a lot closer to 0. You can calculate the correlation coefficient by hand, but it's a lot of work. Luckily, our graphing calculator can do it quite easily. So you have to work with turning on your correlation coefficient. It is not something that comes automatically. It will actually be on the screen when we do our linear regression if it's turned on. It's not turned on right now. So you can hit mode up and turn your stat diagnostic on. So mode is the button just to the right of the second button. So if you hit mode, you want to go up. And, oh, well, on mine and maybe on yours, it's the same thing. Stat diagnostics right here. On one of the older ones, you had like a window or a menu that you had to change. So stat diagnostic right now is off. You see it blinking. We want to go turn it on and hit enter. And then you can second quit out of that. Now, anytime you clear your calculator, it will turn your stat diagnostic off. But if I do stat right 4, enter, 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 I now have my slope, my y-intercept. You're going to ignore this one. R squared for you right now is garbage. Okay, now when it comes to Mr. St. John's class, that will mean something else to you. For R squared, you ignore, and you are interested, there's your correlation coefficient, 0.98. And so whatever data this was that we were working with, we were really close to a +1. And so that would mean that we are dealing with a really strong set of data. Okay, and so this R value has meaning to it. And you're going to, in this next part of the lesson, you're going to learn what to say and what it means and all of that kind of stuff. But you're looking at what number you have here and basically being able to give it and then being able to also interpret it. All right, so we're going to write the equation of the line of best fit, state and interpret the correlation coefficient. So here we have a whole bunch of data. So what I'm going to do is I'm going to type it in my calculator, and you can pause the video, and when you unpause the video, I should be ready to go with my stuff in my table. All right, one of the things that I found out as I was filling out my table, I used my keyboard and actually was typing numbers in. So that might be something that could be a little helpful for you if you try that. It might work. So anyway, I've got all my data in. And so I'm going to now do my correlation coefficient. So stat, right, 4, enter, 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 and my linear regression, sorry. But it comes as a package now. I have my stuff for my line of best fit. Again, we're ignoring R squared, it's trash, and we're going to focus on R, and we're going to state what it is and interpret it. So for this was about shoe size and height. We have a regression equation of y equals 1.61x plus 51.37. And our correlation coefficient is 0.876. Again, the more decimal places you give, the better. Now, we've got to think, and I'm going to draw this right here, this picture that was earlier in your notes. We've got to think about where these numbers fall. There's 0.5, there's -0.5, and so 0.867 is like right here on the grand scheme of things, right? Because this right here is 0.75, so maybe a little bit further to the right. Okay, so it is really close to 1. So 0.876 means that there is a strong positive. Now, I pick strong because that's close to 1. I pick positive because it's close to positive 1, not negative 1. And then I'm always going to put linear correlation, okay? Because this R value only applies to linear functions. So it can't apply to nonlinear functions. When we talk about nonlinears, we just kind of ignore the whole R thing. And there's some other things that you can do with that, but we're just focusing on the linear piece, okay? So 0.876, strong, positive, linear correlation. All right, so here's another one. We're going to fill in the table. I'm going to do it lickety-split. You can work on getting that into your table, and then we'll come back and we'll talk about how to find the linear regression and interpret the correlation coefficient. All right, I've got my table filled in. Hopefully you have yours filled in. Again, this would be something that I would be like, hey, we're doing in the classroom right now. You're punching the buttons. I can't do that other than tell you right now, hey, you should be punching buttons. If you are choosing not to do this, you are not going to know how to do this when it comes to be end of course time. I cannot stress that enough. All right, so for some reason we've got temperature and number of customers. I'm not sure what this is about, but we're going to write our regression equation, and we're going to hit stat right and 4. Stat right 4. Enter, 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 enter. And there's our regression equation. So we've got y equals 11.63x minus 420.55. And our correlation coefficient is 0.094-ish. And so what does that mean? Well, that's really close to 1, right? So that means that it's strong. It's a positive number, so it's a positive. So if it was a negative, this 0.904 would have been negative. So it's a strong positive linear correlation. Now, if I get really close to 0.5, maybe it's 0.56 or 0.43 or something like that, then I'm going to start saying it's a weak positive. If it's a negative, I'm going to throw that in there instead of positive. So you're learning what kind of things that you say, but in this case, and in all your cases that you're going to be writing, you are going to include the words linear and correlation. All right, so we've got write the equation line of best fit. We got some more. So this is a shorter one, so I probably will not pause the video to get the table in. Eight, 13, 18. All right, so we're going to do stat right 4. Again, this is just making sure we know our calculator, how to access things. Enter, 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 enter. And then we've got our regression equation, y equals 2.49x plus 1.47. And the correlation coefficient is 0.909 or 0.91. These all happen to be strong, positive, and they're linear correlations. But don't just expect that to always be the answer. It just happens to be the same thing keeps popping up. So that means whatever variables we're looking at are at least seem to be closely related. Number of hours of sunlight, exposure for each plant, and number of tomatoes on each plant. So as hours of sunlight increase, we should expect tomatoes on the plant to increase. All right, so I'm going to have you pause the video and try to work this out yourself. All right, I've got my table in. And so we're going to do stat right 4, enter, 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 enter. And there is our regression stuff. And ooh, look at that correlation coefficient. So regression equation is y equals negative 0.0071. Might as well. X plus 51.17. You have to put that X in and you have to put a Y equals in front of it. It's not an equation if you don't have that. All right, we've got negative 0.97. You cannot lose that negative. Sometimes people, it blends in with the equal sign and people just skip over the negative. Do not do that. And so what that means is we have a strong, because that's really close to -1, so it's strong, but it's a negative linear correlation. See, not everything is a positive, strong positive. All right, so that means as something increases, something decreases. Let's go back and look at our variables. Well, we've got weight in miles per gallon. So as our weight increases on our car, our miles per gallon, how well our car goes on a gallon of gas is going to decrease, because if it's heavier, it takes more gas to move it. So that will be a strong negative linear correlation. All right, so that's it for this lesson. So you're playing around with graphing calculator still. You need to contact me if you are having trouble with the graphing calculator, and we need to work out those issues. So when you take your quiz on Friday, you have how do you write a linear regression, how do you, or what is the correlation coefficient, and then what does the slope mean? What does the y-intercept mean in terms of the context of the situation? And then what does a correlation coefficient mean as far as, is it strong, is it weak, is it negative, is it positive? And then of course it's a linear correlation. And this will be on the end of course. I would bet money on it. Haven't seen them, but I would bet money on it with the amount of stuff that they have in the standards about slope and lines and all of that stuff. You're going to get some line of best fit things as well. All right, guys. Hope you're practicing, getting ready for EOC. I'll see you guys in the next video. Bye.